Good afternoon. Thanks for joining us here at the NASA Johnson Space Center. I'm Gary Jordan. Hope everyone stayed safe during the crazy ice weather that we've been having lately. But today, January 18th, we're going to be talking about the two upcoming spacewalks that we have later this month. First, Spacewalk 47 on January 23rd, and then Spacewalk 48 on January 29th. The main purpose of the upcoming spacewalks is to replace one of the critical components on the station's robotic arm, the Canadarm2. But I'm not going to be talking about it. With me are a panel of experts who are going to tell you everything you need to know about these upcoming spacewalks. Starting right next to me, we have Kenny Todd, the Operations Integration Manager for the International Space Station Program. Then we have Tim Braithwaite, Liaison Office Manager for the Canadian Space Agency. Down the line is Zeb Scoville, Flight Director in Mission Control Houston. And then last but not least, Sarah Corona, the lead Spacewalk 47 and 48 officer. So as usual, we'll start with a few remarks from our panelists here, some of our experts, and then we'll kind of open it up for questions for the remainder of our time, starting with folks here in the room, and then opening it up to the phone bridge and those following along on social media. If you're calling in on the phone bridge, again, it's *1 to ask a question, *2 to cancel the question if it's already been answered. And then if you're following along on social media, we'll be using the hashtag #AskNASA. We'll read those aloud here in the room and have some of our experts answer that. So with no further ado, I'll hand it over to Mr. Kenny Todd for some opening remarks.
All right, thanks, Gary. First of all, Happy New Year. It's great to see everybody back again. And we just finished up a very busy and challenging 2017. In fact, right up to the very last day of the year. As most of you know, in the mid-December timeframe, we launched and received the Dragon capsule, SpaceX 13, we called that mission. Brought several thousand pounds of science and consumables, and I think some goodies for the crew in there as well. So that's always a very good thing to receive at the holiday time frame. But indeed, the crew did work quite a bit through the holiday period. Also, a couple of days after we got the SpaceX Dragon on board, we had what we refer to as a Soyuz rotation, where we returned the crew that was on 51S. And then a couple of days later, actually received the crew from 53S. So we had 3 new crew members in Scott and Kanai-san, our JAXA astronaut, as well as Anton on the Russian segment. So anyway, it was great to have those guys on board. They fit in very nicely and joined the 52S crew, and everything's been going very well. The primary job first after they opened the hatch was to keep pressing on SpaceX 13, and I'm glad to report that mission was successfully concluded on Saturday with the landing of the Dragon. Everything went extremely well, and in fact, a lot of the early science that we had to get out of the module is already in the hands of the principal investigators, some as far away as Europe. And all the work that needs to be done here on the ground to process those samples is in work. As far as the nominal cargo that was in the module that arrived back here in the Houston area yesterday, and so given all the weather that we've had recently, hats off to the team that was able to process that cargo and get it returned back here to Houston, so that we can again get all the different items out to the different owners of that hardware. So it was just a great mission. And now with that in our rearview mirror, a lot of effort on board and here on the ground getting ready for these EVAs. They're going to be going on the next couple of weeks. And we'll talk to the specifics. The folks to my right will talk the specifics to you. But again, that is going to consume the USOS crew time over the next couple of weeks, and we're excited about getting this work done on the Canadarm. So anyway, we're in the full throes of that. On the backside of these EVAs, we'll be heading into February, which we'll see a few things happening down on the Russian segment. Our Russian colleagues have an EVA on the 2nd of February. They're going to remove and replace an antenna on the outside of the Russian segment. So we'll be working with them between now and then, making sure that we're all ready to go to support them in that effort on the 2nd of February. Once they're done with that in the middle of February, about the 11th, we'll be we'll be hopefully welcoming a new Progress on board. They're going to launch that as the schedule stands today on the 11th of February, and I haven't heard anything that would cause them to detract from that. So we'll be looking forward to that activity. After that, at that point, it's a sprint to the finish of increment 54. The Soyuz 52 Soyuz will be ready to make its trip back to Earth on the 27th. I believe that's GMT. That will undock the Soyuz and return Joe and Alexander and Mark back to Earth. So anyway, we're excited about getting those guys back. They've done a fantastic job, and between now and then, there's plenty of work left to do. With that, we'll be looking into the March time frame. We'll start March. The first couple of weeks, we'll be at 2 USOS crew with Maker and Nemo, handling all the activities on the USOS. And at the middle of March, we'll see the next launch of Soyuz coming up. I believe that'll be a 54S coming up. And again, we'll receive on the USOS, we'll have Drew Feustel and Ricky Arnold. So again, we're excited about the way the year is starting out here relative to keeping the crews coming to and from station. So once we get the 54S crew on board, over the next couple of months, we're going to see quite a bit of activity on board in the vehicle traffic area as well as EVAs. We'll be looking at SpaceX 14 and OA9 in that time frame during that 6 crew time frame. In addition to that, we're talking right now probably on the order of 2 to 3 EVAs in the April-May time frame. So if you like EVAs, once we get done with these, then that's going to be the next time frame that we'll probably be talking about spacewalks. But anyway, that kind of gets us out through the middle of the year. In terms of at the program level and things we got going on. When we look at what's happening here in the very near future with these EVAs, when we were here back in October talking to you, we had originally baselined a set of EVAs that was included swapping out one end of the arm, the latching end effector that Tim will talk to you about. We had that on our horizon at the time. It was kind of a normal wear and tear type of issue that we were dealing with, and we baselined the removal and replacement of that with a spare on station. Unfortunately, before we could get to that EVA, we had another issue that the team found with the other end of the arm, and so we did a quick resort of the EVA in October to go do that replacement instead, and we took this particular, what I term normal wear and tear type of remove and replace, and we moved it out here to after the first of the year. So that's going to be the heart of what's going to go on over the next couple of EVAs. The intent on the backside of the EVAs is to have one of the latching end effector that we took off in October to actually have it in the airlock, stow it on station, and try to return it so that Tim and the Canadian Space Agency can do their standard forensics on it, try to understand what happened, and then and equally as important, put it in the process of refurbishment so that it'll be ready for program support going forward. This arm has proven its value way more than I think we ever thought it could. It just continues to perform and excel, and we're looking for newer ways to use it, and with each time we put the challenge out there, we are seeing the arm continue to support. So anyway, we're excited about doing this work and looking forward to again getting this new latching end effector put on the other end of the arm and positioning ourselves to go forward for the long term. As far as the EVA goes, I'm not hearing anything suits-wise. Everything looks good. In fact, we have a new suit on board that we just launched in SpaceX and in the SpaceX Dragon, and so we're excited about having a new suit on board. Again, that'll be there for years to come and able to support the program. So we're very excited about that. We'll do a mission management team readiness on Monday. just to check all the boxes, make sure there's nothing out there that folks are worried about. But at this point, everything looks very good heading into our first EVA on Tuesday. So with that, I'll hand it over to Tim and get his thoughts.
All right, thank you, Kenny. Well, the Canadian Space Agency is really pleased to be here again, now ready to start part 2 of this planned maintenance activity to replace the 2 Canadarm2 end effectors. So, as we demonstrated last October, Canadarm2 is maintainable in space. Every component of the arm from one end to the other is physically replaceable on orbit, either by spacewalking astronauts or by our 2-armed robot, Dexter. And what we're going to do next Tuesday is replace the second of the original Canadarm2 end effectors. Last October, we did Lee A. The arm is symmetrical. It looks very similar, so we put a black stripe on one end. That's how we know which end is end B. So we're going to do Lee B next Tuesday and swap that with a spare that's stored outside the space station. That spare actually launched on a space shuttle back in 2009. It's been stored outside the station since then. And again, we use these words latching end effector. We simply call it a Lee. So Lee looks a bit like this. In fact, it's about 1 meter long, roughly cylindrical, weighs a little over 200 kilograms. This is a complex mechanical package. This does all the hard work of grasping physical interfaces, whichever end the arm is, as the arm is reaching out, whether the arm is walking end over end around the space station, which it does a lot, or picking up Dexter, our 2-armed robot, to do space station maintenance, or catching free-flying cargo vehicles as they fly up to resupply the space station. This is where all of that work's taking place. Complex mechanical package and also connector mechanisms so we can provide power, data, and video to that package, whatever it is. So since it was launched in 2001, Canadarm2 has been there's been a lot of very intensive robotic activity, including space station maintenance. About 3 years ago, we started monitoring, as Kenny said, normal wear and tear in the arm. This was in the end effector mechanism specifically, and this manifested as increasing motor currents going to those mechanisms. That's actually what we designed the system to do. This was designed for the long term, and to compensate as the system aged, it naturally drew more current to get the job done, and it kept doing that. And we were able to monitor that over the course of years. So during 2015, we physically lubricated mechanisms in both ends of the arm. That was done in 2 separate spacewalks back in 2015. We saw a real improvement in the Lee performance after that, and that bought us a couple of years. But then last year, we started more intensive planning, knowing that we were going to replace both Lees. The first we did last October, and of course, here we are talking about the second half of that job. So last October's spacewalk was vital. That immediately restored the arm to full operational capability. All the way through this time, there has been the steady stream of free-flying cargo vehicles. As Kenny said, we dropped SpaceX 13 just last weekend, and that schedule is unremitting, and we have been able to schedule this maintenance activity in between those, so all the needed work of space stations being done. I'll tell you where we're going to end up after all this is done. Zev and Sarah will talk about the details of how we're going to get there. After these 2 EVAs, what is now Lee B today at the end of the arm, that's going to be on the mobile base. We have an end effector there that is a long-term stowage location. Sometimes we need to place large objects there temporarily. And it's a much lower duty cycle there than on the arm, which is always real busy. So what we expect is that Lee B will actually be able to see out the rest of the space station program in that location, which will be great because we won't need, that saves us a spare effectively. What was Lee A back in October that we placed on the mobile base, as Kenny said, that's going to come inside with the crew at the end of this second EVA through the airlock. It will be stored in the space station for a few months, and then will return inside a Dragon capsule later in the year. From there, it'll be returned to our prime contractor, McDonnell Detweiler in Brampton, Ontario, and they will start the long process of refurbishing that system, cleaning it up, getting it ready to return to the fleet as an operational flight spare. And of course, we're going to use the spare that's outside on the truss, and that will go on the arm this coming Tuesday. Just a side note, we actually have another spare Lee on the ground that's ready to launch, and we're expecting that's going to launch this next year. So at that point, Canadarm2 will have fresh hands and be ready to get about the business of the rest of the program, really well postured to do all of that space station maintenance, payloads that rely on Dexter to be deployed and operated, free-flying cargo vehicles. And we're delighted to be here again with our partner, NASA. Really pleased, too, with Canadarm2 and Dexter really exceeding all of our expectations. Worth noting that these original Canadarm2 Lees both comfortably exceeded their design expectation, lasted years longer than we thought they were going to. So we're really pleased with that. So we're delighted to be here, and hand it over to Zeb to tell us how it's all going to work.
Great. Thank you, Tim. So great summary by Tim and Kenny talking about sort of the big picture leading up to these spacewalks. We've been focusing on getting the cargo missions behind us, and now the crew is really dedicated to getting the Road 2, as we call it, activities set for these EVAs. There's a lot involved with getting the spacesuits cleaned and maintained, making sure that they're in good working order. The crew's been working on that over the last couple of days. Just this morning, they did sort of a dry run of their EVA preparations where the crew gets in the suits and makes sure the sizing is all as expected and the suits fitting well for a 6.5-hour EVA. They had some minor adjustments to the sizing to make sure they fit, but they're in good shape. The suits are ready to go. The crew has some work over the coming days to configure tools, study some of the procedures, and some conferences with some of the EVA specialists to make sure they're all set. Doing the first EVA, we'll have Mark Vandehei. You may also hear him referred to as Sabo, and he'll be going out with Scott Tingle. He might be referred to as Maker. You might hear those names thrown around, but that'll be our EVA crew for the first EVA. Joe Acaba will be inside helping the crew get suited up, and then he and Kanai-san will be working at the robotic arm, driving the arm during the EVA from the inside. So that's sort of with the makeup of the team for the first EVA. On the second EVA, on the 29th, we're going to change things up just a little bit. Again, it'll be Mark Vandehei going out in the EV1 position. And then Kanai-san, also referred to as Nemo, will be going out in the suit and the suits together as EV2. And we'll have Maker working at the arm with Joe Acaba again. So that's sort of how the team's going to be put together. We've got folks on the ground who have spent many runs in the neutral buoyancy lab in the big swimming pool, reviewing the timelines and getting them really about as efficient as you could. They've really exercised this timeline to work through any potential contingencies and make sure that the procedures and the ground team is ready to go. So with that, I think we're in great shape coming into the EVA next week. With that, I'll hand it over to Sarah.
Great, thank you, Zeb. As everyone mentioned, there's been a lot of planning that has been going into getting these spacewalks to be as perfect as we can make them. We've been working very closely with the Canadian Space Agency, the MDA Corporation. I also want to take a moment to mention the folks on my EVA team that are going to be in my back room that have worked to get us where we are. So that's going to be Scott Ray, Greer Wilt, Michael Dino, and James Gustad. Also wanted to thank the increment team who are getting our suits and airlock and tools ready for us, and that's Sandy Fletcher, Farouk Sabor, and Mark Wilsley. So with that, we'll just go ahead. We've got some videos to show you the choreography of these EVAs, and so we can go ahead and start that. I'll be talking to the screen, explaining things as they go. So we can go ahead and start. So with EVA 47, as was mentioned, Sabo is going to be EV1. He is going to be wearing the red stripes, and Maker is going to be EV2 in the white stripes. So first, they're going to head off. EV1 is going to be going to ESP2, and essentially they're going to be at ESP2 for this entire EVA. You see him translating to the work site, and he's going to be getting a foot restraint that he's going to be in. In the meantime, Maker is going to get another foot restraint and is going to be meeting him at this work site. So at ESP2 is where we have our spare Lee. You can see this on the screen here. It is on a flight support equipment pallet. There's some prep work that needs to get done before we can install it onto the arm. So there was some MLI that needed to remove some blanket coverings. It's also secured in a parallel position by some clamps. You can see them here in the diagram. There's 4 clamps on this. The crew will need to release all 4 of them. The video is just going to be showing 2 that are released. So once those clamps are released, this Lee is going to be pivoted up to the vertical position, just like that. Okay, there's a little bit more prep work that the crew is going to do at this point. There are some bolts that have that secured in place. We call them expandable diameter fasteners, EDFs. And I have an EDF here, actually, so if you'd like to pause the video, I'll go ahead and just show you those. We are going to be working with these expandable diameter fasteners throughout the entire EVA. It's a great piece of hardware, so it's essentially a bolt, but if you see it, there's no screws on it. So what happens is there's a post that these are going to be inserted into, and the crew members are going to be using their drill to drive these bolts. And what happens are these collets just expand, and that's how it's secured into place there. So it's very refined, and there are 6 of them that are on the Lees themselves. So we'll be talking about EDFs throughout this entire 2 spacewalks. Okay, you can go ahead with the video. So that's just some prep work that they're doing on that spare Lee. Once it's prepared, they're going to go ahead and bring Lee B down and work on removing those EDFs. Again, there's 6 of them. So once those are removed, they're going to release the Lee from the end of the robotic arm. Once it is released, Sabo is going to be holding on to this Lee, and the crew is going to work together to get into position to install it on the temp stow ring, which was on that flight support equipment. And so right here you can see this is the spare Lee, and they're going to be putting that Lee that was just removed from the robotic arm in this temp stow ring, and it's going to stay there in between EVAs. They also need to swap cameras. There's a camera on the arm, but not on the spare Lee. So they're going to swap the cameras and then remove the spare Lee from that FSC. Again, work together to maneuver themselves to get back into a position to install the Lee back on the end of the arm. So at the end of the first EVA, we will have Lee B, the end of the SSRMS, functional. And as I mentioned, we are going to be temp stowing that other Lee in between EVAs, and we'll be able to finish our whole rotation process at the end of EVA 2. So once that's complete, that's the primary objectives of the EVA. If we do have some time at the end, we do have some get-aheads that we could do. And that would be before both crew members head back to the airlock. And that's the conclusion of EVA 1. So with that, we can move right into the second spacewalk, US EVA 48. So again, Sabo is going to be EV1 in the red stripes, and Nemo is going to be EV2 in the white stripes. And at the start of this EVA, Sabo is going to be going back out to ESP2, and he's going to be getting that foot restraint, and he's going to be installing that on the end of the SSRMS, so right onto the Lee. The Lee that was changed out the first EVA, he's going to be now essentially riding on that Lee for this entire EVA. So you can see him getting into that foot restraint. Meanwhile, Nemo is going to be going to the work site of this POA location, and Mark is going to meet him there. So this is showing Nemo going to that work site. And you can see the Lee in the background. So once he gets there, he's going to be preparing this Lee a little bit for it to be changed out. So we, again, need to change out the cameras on these Lees. So you can see him removing that camera, and he's going to put it in a bag, and it's going to be staying in a bag for the remainder of the EVA. Well, not the remainder until the end of the EVA when we need to install it back onto the new Lee. So while he's doing that, Sabo is working on meeting him back at the work site. And again, together they're going to work to remove this Lee. So again, we've got the EDFs that we're interfacing with, and there are 6 of them. Once those are released, the crew is going to work together to remove the Lee. And Sabo is going to hold on to it, and the robotic arm is going to be flying him back to the airlock, where we're going to be putting that Lee inside and taking it back IV with us. So Nemo is going to meet him back at the airlock, and together they're going to install it where it will remain for the rest of the EVA. Once that's complete, again, Sabo is going to be flying to the next work site, which is going to be ESP2, where that Lee is in that temp stow ring. And Nemo is going to translate out himself and meet him out in that area. So together they're going to work to remove this Lee from the temp stow ring. Again, we've got the EDFs to remove. On the temp stow ring, there's just 4 of them that are installed. Thus, only 4 need to be removed. So once that's released, Sabo is going to, again, hold on to that Lee, and the robotic arm is now going to move him back to the work site where it's going to be installed onto the POA. So Nemo's going to clean up a little bit at that work site and then meet him back at this location. So again, together, they're going to install that Lee onto the POA structure. And we've got the 6 EDFs to be installed. Once that's done, Mark is going to be heading over now to the base end of the arm where he has another task to do. Nemo is going to be cleaning up the worksite some, and he's going to be taking that camera that was stowed in the bag at the beginning of the EVA and installing it onto this Lee. So this is showing Sabo at that other worksite. So there is a grounding strap that we have that Sabo is going to be installing around Lee A. So again, this was the base of the arm. And the purpose of this grounding strap is once it's installed, we should be able to change out that camera robotically if we need it to. If it were to fail, this strap is going to help be able to change it out robotically. And that ends the prime tasks of the EVA. If we have time for get-aheads, we've got things on the back burner for them to go and do. This concludes the end of the content. Both crew members would come inside.
Fantastic. A great overview of the EVAs to come, and then also all the prep work that was done beforehand and things to come afterwards too. We got a lot of activities coming these next couple months. So with that, we'll open it up for questions, starting here in the room, and then obviously if you are listening on the phone bridge, again, *1 to ask a question, *2 to cancel it if it's already been answered, and then if you're following on social media, it's the hashtag #AskNASA. But we'll start here in the room with Mr. Carreau.
Thank you, Mark Carreau for Aviation Week. I'd like to ask a big picture question to Kenny Todd, if I might. There's still discussion and talk of a possible government shutdown. If that were to occur tomorrow at midnight, what would that do to the EVA, but your EVA plans? And also, could you talk bigger picture about station operations overall? Could you talk about whether you can continue to operate with the crew as normal, and what would you have everything staffed in the flight control center? If something untoward happened, would you be prepared to deal with it?
You bet. Thanks, Mark. Yeah, of course. When it comes to station operations, we have a plan. Mission essential critical personnel will be on site. We'll be working. We'll be continuing the mission. So we don't see that as any kind of impact going forward when it comes to our daily operations. We have plans laid out over the next several weeks and months. In terms of finely detailed plans, I would say it's probably the next 3 to 4 weeks, and there's nothing that's will be impacted by that. So no, we'll see all the same the normal mission critical folks on site, and we'll continue to execute the EVA plan and everything that's coming in the near term after that. So no impact.
Great.
Hi, Robert Perlman with CollectSpace.com. For Tim, when this is complete, the arm will have 2 new hands. Are there other components on the arm that have wear and tear concerns, or that you know that you'll need to replace moving on?
Great question. We don't have anything specifically scheduled that I can think of. We continue to monitor the whole arm. We've had a few camera failures over the years, and those have been replaced. And but everything's working. Nothing specifically scheduled right now. We will react as things occur and deal with it. But the important piece for us, our focus here, is to get what was originally LEA back in October and get that on its way back down to the ground so we can start that refurbishment process.
Judas and Sarah, ABC News for Sarah. What kind of get-aheads are on your list if the time allows?
Yeah, great question. I was with Tim's comment of anything else that needs to be done with the arm. We have done lubrication of the latches on all of the other remaining leads, and we found that it's been doing great work. Just kind of it helps with the wear and tear. And so the spare Lee has not had that lubrication, so that's a possibility at the end of EVA 2 to do. Another one, there's several tasks that if there was a critical contingency EVA, a component on station that failed that we need to go out EVA quickly to do. Some of those tasks or some of those EVAs can be extremely long, like 3 or 4 EVAs long. So there's tasks that we're doing to help us be in a better position so those EVAs wouldn't be as long. So we've got a couple of those with a pump module, an FHRC, what else? And then there's also another get-ahead task we have. It's a RMCT deploy. I'll need to refer to Tim on what RMCT stands for, but it's on SPDM. It's going to give more capability. Right now, they're down one RMCT, and so we're going to be installing the other one on that if we can get to it. I think that summarizes our get-aheads.
Yeah, that was a robot microconical tool.
There you go.
Thank you. So for those on the TV that weren't able to hear, the question was about the get-ahead task. Just for those in the room, if you do have a question, just wait for the microphone to get around so we can make sure that all these are captured on for everyone to hear. But are there any more questions in the room? If not, we will go to social media.
All right, we have a question on Facebook from Tracy. She wants to know if they have safety mechanisms, if something should happen, like their tether breaks, what would they do?
I can take that one. So the crew members are tethered all of the time. They've got a tether that's 85 feet long, and we actually have a tether pack. So we have 2 of those in place. So that as they're translated along structure, they always have a line on them. When they get up to a work site, they actually put another tether on. It helps them actually just keep up to the work site, but it also acts as keeping them secured to structure. If any of those were to fail, the crew members also have their safer. They've got their jetpack. So that's the simplified aid for EVA rescue, that if they were separated from station, they could fly back using that safer.
Thank you. Another one on Facebook from Akshay. Does it feel cold during the spacewalk if the sun is not on your side?
I will take that one also. Okay, so the spacesuit is a wonderful machine. They have a cooling garment on them that covers their legs and their arms. You can get cold water going through it. You can get warm water going through it. The spacesuit itself, it's very insulated. We haven't. It depends on where you are. Some crew members have noticed it, particularly maybe in their hands and their feet, that they may get cold. For the hands, we do have glove heaters in there, and we'll kind of give them a heads up. Hey, nighttime is coming, especially with Sable being out on the arm for EVA 2, and he's going to be carrying a Lee. We'll give him those heads up to help him stay warm if we are going to be in those conditions.
Gotcha. Another one on Twitter from Ryland. How old are the spacesuits on the space station?
Okay, I can give it my, yeah, go ahead, you can.
Okay, so the spacesuits are originally designed for the space shuttle program. Those were first flown in the early STS days, so they were designed in the late 70s with first operational use in 1981. Of course, that technology goes back to prior programs. It's an evolution from the Apollo-Soyuz, going back to Apollo and even Gemini. So there's been a evolution of the spacesuit technology designs, and I originally even started with some of the high-altitude Air Force pressurized suits that then became some of the early Mercury and Gemini suits. And so that's sort of how the design has evolved and has been carried forward into the space station program.
I think the important distinction I would make there is that's on the design side, it goes back that far as the technology that's in the suits, and they've had upgrades over time. But the suits themselves are relatively new. In fact, as I said earlier, we just flew up a brand new suit. So while we may be relying a little bit on the older technology and the tried and proven design and some of the system level upgrades that we've done over time, the suits themselves, in terms of numbers of EVAs and how long they've been on orbit, it's just a period of years, several years. And over the last couple of years, we've introduced some new suits on orbit.
And the one that was just launched would be good for 5 years on orbit.
Thank you. One more from Twitter, Nicola. How often do you do spacewalks? Whoever wants to answer.
Well, let's see. In any given year, we're going to do somewhere probably between 7 and 9 planned, at least I see that over the foreseeable future here. When you look out at 2018, we're going to do 2 now. We'll probably do about 3 in the spring time frame, and then if the flight rate keeps up like we think it is, we'll probably have an HTV later this year, and that's going to have some batteries on it, and that's going to be somewhere between 2 and 4 EVAs. And so anyway, that 7 to 9 is probably a good range, and could be 1 or 2 on either side of that. But if anything, I would say it might be a little on the low side. So we may see a couple more than that, but that would be a good range to think about. And generically, that's probably a pretty good answer going forward for the following years.
Thank you.
Very cool. Okay, any more questions in the room? Mr. Crow.
Thanks. It's Mark Carreau again from Aviation Week, and I know this is Flight Control Room 101. Maybe Zeb could answer. How many basic positions do you have in the control room that even if there's a shutdown, that you will keep staff to watch over all the activities?
Yeah, so good question, Mark. As Kenny said, the critical nature of spacewalks being a highly dynamic operation, we really make sure we're staffing that effectively to make sure we're both meeting the program's objectives, but also making sure we're keeping the crew members safe there and giving them the support they need. So there's the flight directors, the communicators, the console positions that are responsible for the core space station system. So there's about 5 people there, EVA and robotics, in addition to some of the other stowage and engineering support personnel over there. So you're looking at the full staffing that you need to be able to meet the EVA objectives.
Very cool. Any other questions in the room? Any coming in on social media, Megan?
I think we have one or two more. Vladimir on Twitter wants to know what happens if an astronaut was accidentally hit by space junk. How do you protect for that, and how do you monitor that?
So the spacesuit itself was designed to be able to take any impacts on that. There's also, before we go outside, people do monitor. We're not going to send them out in a storm, and so there's the suit itself has that protection from micrometeorites.
All right. And one more on Facebook from Trace. How much oxygen do they have? How long can they stay out safely?
So that depends on how much they're breathing. They've got some oxygen tanks that is pressurized to about 850 psi. Generally, you can get, it's designed to have 7-hour capability. Generally, you can get a lot more off of that. So we've got primary tanks, and we have a secondary tank is only to be used in an emergency. With the oxygen as well, that one is great where you can actually just go back to the airlock and hook up your umbilical, and you can refill your oxygen tanks. So oxygen is typically not our limiting consumable when we go outside. Again, it's designed for 7 hours, but we usually get much more off of that.
Fantastic. Okay, I think we have a couple callers that are calling in right now, so I guess we'll go to Mark with SpaceQ and Space Ref. Mark.
Yes, this question is for Tim Braithwaite. Tim, it's a two-part question. Just correct me, was the replacement of Lee B planned for this time? And secondly, once Lee A is refurbished and returned to station, is there any thought to bringing back Lee B to get it refurbished in case it's needed in the future? Thank you.
All right, thank you, Mark. Good question. As Kenny indicated in his opening comments, we'd been preparing during last year for end effector maintenance, and the preparation we were doing was, for the most part, generic. When it came time for that first EVA in October, we had actually been considering to do Lee B first, but at that time we looked at the data, decided that it was the smarter thing to do Lee A. The mechanism was showing that sign that it was time to do that. So we went ahead and did that. That was a relatively easy change to make. And again, did that knowing that we had the plan to go ahead and do the second one coming up, and here we are in January. So we did change the order there based on the data we were seeing, but at the end of the day, at the end of this second spacewalk that's coming up, we're going to be in the same place that we planned to be, with Lee B on the mobile base and what was originally Lee A returning to the ground. Now, remind me the second question. Oh, refurb, yeah. So Lee A on the ground, there will be a process that we need to go through, and it's very interesting. This object has been in space for 16 years. It has seen a lot of action. So there's a lot that we can learn from examining this as we go through the refurb process. But as Kenny said, our primary need is to get this turned around and ready to fly again. Whether we decide to actually do a preventive replacement on something that's actually working is something that the program would really have to consider. We'd need to weigh what's the best use of those resources. The beauty of having this end effector on the mobile base is that it's used really quite lightly. The end effectors on Canadarm2, it's really in constant use. There's maintenance, there's these free-flying vehicles that are coming all the time. We use that end effector to stow something on the mobile base on average about once a year. So the duty cycle is really very low. And based on the condition that we see Lee B being in, we believe that it can last out the rest of the program. Unless something changes that, I consider it likely that we leave it there and let it do its thing and not commit a spare that we didn't need to.
Fantastic. Thanks, Tim. Another caller we have, Bill Harwood from CBS. Bill.
Hey, thank you very much. I'm not sure who the question is for, but it's a follow-up to Mark Carreau's shutdown questions. Where does PAO fit in the world of essential personnel? Meaning, if there's a spacewalk next week and the government is shut down, will it be on NASA television? If not, can we expect any web updates? I mean, what's the scenario there? Thanks.
Well, I guess I can answer that question. Being in PAO, again, that's still being assessed at the headquarters level, so we don't really have a decision yet. But we'll hear from down there as to what we can find. Whether that's going to be TV or web updates, still TBD. Okay, so we'll go to Bart from Spaceflight Insider. Bart, you're on.
Hi there. Question is, given the heavy workload that the leads have been taking on in the past 16 years or so, is the new part upgraded in any way to account for the increased workload?
Okay, so good question. Has the lead been upgraded? We have, over the last few years, as we described, got into the practice of lubricating these end effectors. Beyond that, it really is pretty much the same system. One thing, though, I mean, we got through 16 years, and I think it's fair to say that during the course of these 16 years, we have been refining our ops techniques, how we use the arm, the way we run these mechanisms. And our ops team, we have a joint ops team between NASA and CSA. We are a lot smarter today than we were when we started out in 2001 about how to run these mechanisms. We have updated the software quite a bit and reduced the rates at which the mechanisms sort of bottom out. So I think it's fair to say we're a lot gentler on the end effector mechanisms than we were when we started out. So we have a reasonable expectation that these new end effectors, effectively they are new end effectors that start this year, are going to last at least as long or longer than the original two that we're just now replacing.
All right, and I think we have a follow-up question from Mark from SpaceQ and Space Ref. Mark, we'll put you on again.
Yeah, once again for Tim. I'm just curious. How do you know that the spare, which has been outside the space station for 9 years, is ready for service?
It's a reasonable question. We know it was in great shape right before it was launched, and it's been covered and heated out on the truss since then. We have a process whereby after it's installed on the arm, we will run through a series of checkouts to make sure everything's running, but we have every expectation that it will be there as we launched it.
Fantastic. Thanks, Tim. So we'll do another pass around the room, starting over here.
Gina Sinceri, ABC News. I mean, you must keep notes somewhere, Tim, about if I were going to build this thing again, what you've learned over the last 16 years to make a greater, better Canadarm. Is that kind of like some fantasy project you engineers have going?
Well, no, you're right. We take a lot of notes, and we write a lot of lessons learned. There is a whole evolution in space robotics that we've got to, that we are part of here. The arm that was on the space shuttle, which in Canada at least we call the original Canadarm, that was a first generation of this system. Canadarm 2 on space station was a natural evolution of that, built by the same company, now MDA in Brampton. And a lot of the lessons from the shuttle experience were incorporated into the space station system. And now we're looking again. We are actively working on what a Canadarm 3 might look like. And a lot of the lessons learned from space station. This is a long duration environment. We launched Canadarm 2 knowing it wasn't coming home, at least not in one piece. And that long duration experience has really taught us a lot. And yeah, we're absolutely documenting those lessons and going through a design process to take us to Canadarm 3 and beyond.
Okay. All right, I think they have a social media question.
Another one came in on Twitter similar to the oxygen. In case of a solar storm, are there radiation limits for EVAs?
So there's a crew of folks that's their job to make sure that when they go outside, again, we're not going to be sending them out during the highest radiation points. I was just at a meeting this morning that was discussing all of that. So what the crew, when they go outside, they actually have their dosimeter. Thank you. They've got their dosimeters on them. So once they go outside and they come back in, they can analyze of how much radiation they did get. And so people are watching that. The spacesuit itself does have that protection, but we have other means of making sure we're sending them out in a good environment.
The good news about that is when you have solar activity, usually it's a period of days before it actually gets to the point where it's potentially going to impact an EVA crew member or the station. So that's something that we have folks looking at all the time, and it's having an instantaneous event while they're out is probably not going to happen. Again, it just takes a long time when the sun erupts and we have solar activity for any of those particles or any of the rays or any of the things that give us concern relative to the suits or the station or even some of our networks here on the ground. We have a heads up on that. So and as Sarah said, that's the kind of thing that we wouldn't send a crew out in that type of environment. So.
Thank you.
Awesome. Any more questions from the room? I actually have a follow-up question that's kind of bouncing around in my mind. There's a lot of prep work that goes into EVAs before we actually go out the door, especially on the 23rd, and this is weeks prior. So Zeb, from an operational perspective, some of the things that go into preparing for an EVA, preparing the suits, reviewing procedures, those kinds of things.
So I guess your question is, are you looking at what are some of those specifics?
Yeah.
Yeah, okay. So like I said, this morning, the crew did a dry run of their prep procedures. They go through the full suit donning. They take measurements of it. When crews are exposed to a zero gravity environment, their spine actually elongates them. They actually typically grow about 1 inch. And so our estimates of what the correct suit size is might need to be tweaked and adjusted. And so this dry run is to verify that we've got a good fitting suit, and we did that, as I said, this morning, made a few adjustments there. There's tools that they need to configure, the operation of the suit. They really want to know very well where all the tools are, make sure they have the right ones available, but then aren't also over-cluttering their work environment. So making sure they have all the right tethers and tools and wrenches in the right place and easily accessible. You don't want to get outside and realize you need a wrench and it's inside. So there's a lot of preparation for that. This crew wasn't necessarily trained specifically for this exact task when they launched, and so they're given skills-based training on the ground where they say, here's the general skills you may need for a large assortment of potential tasks. But once they get up there, we tell them more specifically what EVA they're going to be doing. And so we'll talk about, they'll review their procedures, they'll have conferences with folks on the ground where we're able to discuss the nuances and the details of the timeline to make sure they have all their questions answered. Let's see, additionally, they'll have some medical fitness evaluations, just making sure they're healthy and ready to go out the door from that regard. And then there's additionally all the robotics procedures. Since these EVAs will be driving the robotic arm while we're replacing it, there's the crew inside that needs to prepare for those procedures, make sure they understand all the trajectories and the planned camera views and so forth. And also with the crew on the arm, if something were to go wrong with the suit, what is the rescue plan? What's the quickest way to get them back to structure, get them off the arm and inside the airlock? So that's just sort of a broad scope. There's certainly a lot more in the details, but that gives you a general picture.
Definitely a lot more in the details, it seems like. So Sarah, for this particular EVA, how long did it take to sort of put the procedures for this together, all coming to these spacewalks later in the month?
Let's see. I think we started gung-ho on it after the October EVAs, and we learned a lot from that, and we went from there. So from October to January 23rd, our procedures should be approved by in a couple hours. Actually, due dates are out there, and actually that's rather fast. We prefer maybe 6 months or so to start that full development. Sometimes it's even longer, but. So I would say the end of October to January is when we were full up trying to figure out how to change out these leads.
Fantastic. All right, any more questions in the room before I ask more? All right, go ahead, Mark.
thanks, Mark Carreau from Aviation Week again for Ken. So if there was a shutdown and it lasted beyond the spacewalks, I guess what I'm really asking is the other activities that the astronauts involved in, quite a bit of research, tech stuff, will that all be supported during a shutdown if there is? And approximately how many folks are involved here in supporting all that on the ground?
I'll tell you, Mark, I'll have to defer the second part for you and go do a little homework and see if I can even come up with that number. But from a space station operations standpoint, we've been up against this threat before, and it really doesn't impact the way we do operations. I mean, the fact of the matter is it's an international program. We're working with a bunch of partners around the world. We're working with a bunch of investigators. Some of this science and so forth has lifetime type of limits to it, and so we really can't be in a position where we can't support the mission. And the mission is as much about the science as it is, we got to keep our crews safe and we got to keep the vehicle flying in the right direction and good and healthy. So there's a lot that goes into day-to-day operations, and we'll continue to do day-to-day operations, and our core mission there doesn't change, which includes supporting all the science too. So yeah, I understand your question, and it seems like in the big picture with everything that's going on that there might be some impact, but relative to day-to-day operations, we just got to keep pressing.
Definitely. All right, one more circle around the room. If anyone has any last questions. Awesome. Okay, so with that, I think we'll start wrapping up here. I wanted to thank everyone in the room, obviously, for your questions, but then those calling in and on social media, great questions just kind of all around. And again, thanks to our panelists, our experts here who know all about these upcoming spacewalks. Thanks for coming here, and best of luck on those upcoming 2 EVAs that we have. If you wanted to tune in to those EVAs, those will be coming up again on the 23rd next week and on the 29th. Both of them will be starting at 4:30 a.m. Central Time, at least from a coverage standpoint, 5:30 Eastern. We're looking to head out the door around just a little after 6 a.m. Central, 7 a.m. Eastern. So if you wanted to tune into that coverage, we're looking at about a 6.5-hour EVA for each of those to replace the Lee on the end of the station's robotic arm. So with that, if you wanted to know more about the International Space Station, as always, you can go to www.nasa.gov/station. So we hope to see you tune into today's coverage, and thanks again to everyone who participated in today's briefing.